right, so if the derivative of e to the x is e to the x, then what do you think the antiderivative of e to the x is? E to the x. It goes both ways. The double derivative is e to the x. The triple derivative is e to the x. The antiderivative is e to the x. Okay, the only thing we're missing here is what do you do when you integrate? You put plus c. Okay. All right, so we know that it's not always x in the power. That's why we used chain rule yesterday to do derivatives. So if you have another power, it's going to work the same way, but we're going to do U-substitution, which we did. I really think that by doing U-substitution in new context is going to help you guys understand the process. Once you get the process down really good, it's going to make everything easier, okay? But it's a process. You don't just go from being horrible at it to being perfect at it. You have to take steps here. We're going to take some of those steps today. So, looking at number 1, we're supposed to integrate this. Do you know off the top of your head what this is a derivative of? No. Okay, that's ridiculous. So that means we need to do U-substitution. That's how you know. A lot of people will be like, when do we do U-substitution? Well, when you can't do it without. Okay, your U is never going to be X, and it's never going to be the whole thing. It will always be part of the problem. Look at this right here. Where is U at on that integral up here in the box? It's the power of E. So let's just take a leap of faith here, and let's see if we can get this problem to work out. So the power on E is negative x squared. Okay. Don't necessarily know where we're going, but we do know the next step is du. The derivative of u. That should equal the derivative of negative x squared, which is what? Negative 2x, and remember we have a dx here. Just like how we did before, this negative 2 needs to get divided over to the other side, and it's ultimately going to go to the front of the integral symbol. And you know what? I'm going to hold off just a second. It's going to go to the front. See how there's also a 3? I'm going to move the 3 to the front as well, so I don't have to mess with the 3 anymore. Now watch this. Okay, I'm going to explain U-substitution again. And I think just having seen it and then hearing it again in a new situation is going to help some of you. This over here, this x and this dx should be in the problem. And it is. There's an x right here and a dx right here. I am going to take out the x and the dx, and in its place, I am going to put the 1/2 du. All right, I've already put the negative 1/2 in. The du we know always goes at the end. So then what was left? E to the u. Don't worry about Toko right now. Everybody else forgot about that. No, not really. I'm not saying it's not possible, but don't worry about that. Okay, let's just pretend that didn't even come up.
At what point of the year do we stop learning anything and start just reviewing it?
Right after spring break, we will have a mini unit, and then pretty much a whole month before the AP test we'll review.
So this is our last unit?
Oh,
Yep.
no.
Okay, let's get back to this problem.
Are you actually sad about that? Like, are you genuine?
All right, okay, shh. Turn around. All right, so looking at this problem, okay, I know negative 1/2 times 3 is negative 3/2. What is the antiderivative of e to the u? We just talked about this. E to the u plus c. Okay, this is why E, yesterday I said E is for easy. You don't really have to do a whole lot compared to other things. All right. All right, can I leave this as my final answer? Right, you guys are good. You know we need to say, we can't leave U right there. We got to go back and put in negative x squared. Okay, so that is how we do U-substitution when there's an E in the problem.
Is that e to the negative x squared?
Yes. Just like how it is in the beginning problem.
Oh,
It's the same thing. How could we check this?
derive it.
Derive it. We should get, I'm going to erase all this now, but we should get this thing right here. If we simplify and derive, we should get that, and we would. I'm not going to spend time doing that, though. Okay, let's look at problem 2. The very first thing we need to do with problem 2 is rewrite it, because there's lots of fractions here, and we know fractions kind of make something a little bit more complicated. So first of all, how can you rewrite that power so that it does not have a fraction?
e to the 2 negative x negative 2x.
Yeah, so 2 divided by x is 2x to the negative 1.
Bless you.
Thank you. Okay, that's it. All right. Divided by x squared is the same as times x to the negative 2 dx. All right, now let's think back to what we did in problem 1. What did we let u equal? This power right here. That's going to be the u. So 2x to the negative 1. Then du would be negative 2x to the negative 2 dx. Remember, when you're deriving, you subtract 1. When you're integrating, you add 1. All right. I'm going to rewrite this over here just because it's too small. I'll rewrite it. Move it over. So du equals negative 2x to the negative 2. Okay, so I'm going to divide over the negative 2. That is something we just do on all the problems. And that number goes out to the front. You can do it later. Might as well do it early in the problem. We know that's what's going to happen. Okay, I know that this e to this power is going to turn into e to the u. What I'm hoping is that what's over here in my du statement is exactly what's in the problem. And it is. Isn't that great? Because if they're not the same, it's a much more difficult problem involving Toko. Do not worry about that. But I want you to anticipate that these things are going to match. Okay? And you replace these two things with a negative 1/2, which we already wrote, and a du. Okay, so look at what we have here. We have the integral of e to the u du. What is that?
e to the u plus.
E to the u plus c. Okay, same as before. Don't leave that as your final answer. You do need to go ahead and replace u with 2x to the negative 1 or 2 over x. You could write it either way. I think most of you would probably do that. And you could check your work by deriving, or you could also check it on the calculator. Okay, and we will look at the calculator in a minute. All right, number 3 we're going to skip for now. We actually can't do that one yet. Again, that had to do with the fact that we're doing 5.4 first, okay? So let's go ahead and do problem 4. All right, now, there's bounds here. There's limits of integration. We'll deal with that in a minute. Our first big thing is, I know I can't integrate that in my head. I've got to let u equal something. Somebody might be thinking, hey, we always let u equal the power on x, so let's let u equal x.
No.
Yeah, so we're never going to let u just be x. That won't help us at all. It'll be the exact same problem, just with a different letter. It won't be any simpler. Okay, so you always have to let u be part of the problem, and I like what a few of you are saying is, hey, we have some parentheses. That's how we started off with U-substitution, so I'm going to use that here. So let's let u be the thing in parentheses, e to the x. So then, what would du equal? E to the x, dx. Which, by the way, is right here in the problem. Both here and here. Okay, so when you rewrite the problem, you have your cosine u And then you replace e to the x dx with du. We got to deal with those numbers because these two numbers are representing x values. We want them to be u values. So let's use our u, okay? So if x equals 0, what would u equal? Why? How are you guys getting 1? E to the 0 is 1. Honestly, if you wanted to write e to the 0 and leave it like that, that would be okay. I'm going to go ahead and write 1 though. What about the lower bound? X equals -1. What would u equal? Okay, remember, we're taking this x value and we're plugging it in for x. So we're going to go e to the -1. It doesn't equal anything. You could rewrite it as 1 over e. I'm going to go ahead and just leave it as e to the -1. That's totally fine. All right, but it doesn't turn out to be like some number. All right. What is the antiderivative of cosine u? Sine u. Now, because I anti-derived, I no longer need the integration symbol or the du. Do I need a plus c?
No, because you're going to subtract on the CJ at the top.
Yeah, I don't need it. Let me explain. Let me do the next step and then explain in that and remind you guys why we don't need the plus c. Although if you wrote it, you're not going to lose points over something like that. Okay, so I don't need to go back to x. I'm good. I'm in terms of u. My bounds are in terms of u. So my final answer is sine of 1 minus parenthesis sine of e to the -1. And that's all we can do. If you had been thinking, but I really feel like we need a plus c. If we had a plus c here, you would have it here and here. And then so they would cancel because it would be like c minus c. All right, so you don't need to write it at all. But if you go through and do that, that's okay. Like if you're like, I don't know if I need it or not, it's okay. What I saw on the test, uh-oh, frozen up here. There we go. Okay, what I saw in the test was some people from this thing going ahead and writing it as sine of e to the x. Like they replaced the u with e to the x because like why not? Right? That's what we did on the other problems. If you do that, that's actually okay. But then you have to go back and use your original bounds. You can't use your new u bounds and then also change the x. You have to be consistent. Watch what happens here. And everything I'm doing in yellow, you don't have to write this down. I'm just proving a point, really. If we plugged 0 in, we would get this. Is this the same thing as what I've written over here in red? Yeah, because e to the 0 is 1. So it's okay if you do want to go back to x. It's a little extra work, in my opinion. But you've got to go back and use your old bounds. Okay? All right, we're going to also skip 5. I'm going to save that for a warm-up tomorrow. And let's look at number 6. Okay, I want you to try to get as far as you can in this problem on your own. Okay, what was the derivative of e to the u again? E to the u. Do we need a plus c? No, but we do need bounds. So, and I didn't show this yet. If x equals 4, what does u equal? 3 minus 4 is -1. What about the lower bound? What did that turn into? 0. 3 minus 3 is 0. You don't need to go back to x once you change the bounds. Okay, so here's a great question. I want everybody to hear. I'm going to repeat the question and we're going to talk it out. Hey, isn't the lower bound normally the smaller number, right? And it is. I can't just switch them because they're in the wrong order. If I decide I want to switch them, what do I need to multiply the whole thing by? A negative, okay? A negative. We could have done that. You could have actually flipped them, and then negative times a negative would become positive.
whatever.
It would be the same. You don't have to do that though. All right, so then we'd plug in the upper bound, minus, and we'd plug in the lower bound. That's it. That's your answer. It's ugly, but it's our answer. If this was on a multiple choice, it probably would be simplified. And I don't know how far they'd go, but I just want to remind you that this e to the negative 1 is 1 over e, and e to the 0 is 1, and a minus negative 1 would become a plus 1. We don't need the plus c because it would be in the first and second part, so it would ultimately cancel. If you had it, plus c here and plus c here, you're not getting points off for that. So if you like it for the consistency, you could do that. All right, yeah.
Can you just put parentheses before the negative?
Sure.
Okay.
All right, let's turn it over and let's look at the back side. And we're not going to do all of these. And before we worry about how to solve 7, I just want to talk about how do we set this up. Okay, what does that mean when it says find the area?
Integrate.
Integrate. Area means integrate. Okay, this whole y equals 0, by the way, just means x-axis, which is always what we're comparing the curve to. Okay, so we're not going to do much with that. So here's our function. We put a dx in, because that's the notation. And then our lower and upper bound are sitting right here. 0 and square root of 6. Okay, that's what this problem is asking you to do. It's asking you to integrate that function from x equals 0 to x equals square root of 6. We could do this one by hand, but we just practiced a few. So let's do this one on the calculator. So go ahead and get your calculator out if you haven't. And okay, I'm going to plug this in up here. You can follow along. I do want to bring your attention to something. Your calculator does not like implied times. You really need to do x times e. And just as a reminder from yesterday, e is diamond x. It's right here. It's the same color as your diamond, depending upon which calculator you have. It's very easy to plug stuff in incorrectly. Put the numbers in the wrong order, leave a parenthesis off. Your calculator is going to tell you if you did it incorrectly. Okay, it's going to tell you by giving you an error. And the other way, like now that I press enter, it's going to tell us because this right here is now in pretty print. And this should look exactly like what I've written on my paper. If I messed up with the parentheses, I'm going to be able to tell just by a quick check here. Like in case these numbers, if I type them in the wrong order, it's going to show on the integral symbol, and then I will know that I messed up. So you get a really weird answer. Okay, not a big deal. 2 minus 2, e to the negative 3/2. Okay, what if you wanted a decimal answer? Diamond enter. You get like 1.554. I did not do that in my head, by the way. That's just off memory from earlier classes. I cannot do that kind of math in my head. Okay? So I want you to be comfortable with the calculator. On that last test, a lot of you did a lot of integrating by hand, and some people made mistakes. If it's on the calculator part, take the easy way out. It saves you time, it's more accurate, but you need to be comfortable with it. You can't be like trying to figure out how to do this the day of the test. All right. Okay, so that was that. We're going to do number 8, and then that'll be the last one we do today. Okay, so first of all, look how the directions, I wanted to say decorations, that was weird. Look how the directions are a little bit different. Solve the differential equation. What this means is they're telling us what the derivative is. So what do you think we need to do? We need to integrate, anti-derive. Okay, so technically the way we've kind of been doing these problems is we've been moving that dx over to the other side. This is called separation of variables. You get the y's on one side and the x's on one side, and then you integrate both sides so that it's y equals. Before we integrate this, I would like to rewrite it. This is like what we did on the front. So I'm going to go through this example a little bit faster. A number like this in the front, just move that to be the beginning of the integral symbol. And instead of negative x divided by 2, let's write this as negative 1/2 x. Now you may be thinking, I wouldn't have thought to do that. Well, here's the deal. You would eventually, because what are we going to let u equal? In this case, negative 1/2 x, which is super easy to derive, right? It's just negative 1/2 dx. If you had kept it as negative x over 2, you might be thinking you need to use quotient rule. All right, and you might be thinking, oh wait, can I write this a different way so that maybe I can get out of quotient rule? Those are the kind of like conversations you want to have with yourself in your head. It's okay to talk to yourself in here. I do it all the time. All right, so how am I going to get this negative 1/2 to the other side? Divide it and it becomes negative 2. So look at what we have here. We already had a 2. Now I'm going to multiply by the negative 2. But what I'm left with here is super easy, just e to the u du. So I'm going to multiply the 2 and the negative 2. Integration, you don't have to do much as far as that goes. And this is what we call the general solution. This would be perfect, except they gave us more information, so they're expecting more out of us. All right? I know. Dang it. All right, so what they want us to do, oh, you know what? I've done this in every class. What do we still need to do here? Yeah. Make that back to negative 1/2 x. Sorry about that. All right. What we need to do is to take that 1 and plug it in for y. We need to take the 0 and plug it in for x, and this is how we're going to figure out what the c is. They're giving us information so that we can evaluate c. You're going to see like numbers like 0 and 1 are going to be the most popular numbers because they're really easy to compute. E to the 0, that's a 1. That's a times 1. So we end up having 1 equals negative 4 plus c. You add the 4 over, and c equals 5. Although that is not my final answer. Your final answer is, you got to rewrite it. But instead of plus c, we're going to write plus 5. Okay, so we've been doing differential equations, just not with e yet. Now we have. Okay, so the goal here is to understand U-substitution a little bit better every day. The big picture of what U-substitution does. The other thing you want to, like a good goal, is to get more comfortable with switching back and forth between deriving and integrating. That's harder to do. It's only going to get easier with practice. And then here's your homework. This homework is due Monday. Oh yeah, Tuesday. I expect y'all to come up here with this assignment on Monday. Just kidding.
Do we get extra credit?
No. All